everybody. Good morning. This is the report presentation of Group 3. Before we proceed to our main topic, I will introduce first myself. I am Christine Saguyong and I will be the one to discuss the whole topic. So in the next of this video, I will introduce my group mates.
You were enjoying nature and all its wonders when you decided to start looking for different repeating patterns. You throw a rock into a pond and see many little circles growing outwards from where your stone hit the surface of the water. The ripples slowly fade away and the pond is still again. These circles radiating away from the point where your rock hit the water are called concentric circles. Concentric circles are a collection of circles of different sizes surrounding a common center. All the circles have a different radius. The radius is the distance from the center point of the edge of the circle. These are many different examples of concentric circles you can find in the world around you. Here is a cut-down tree. There are concentric circles called tree rings, and if you count them, you can determine the tree's age. Each year, the tree grows a new ring. The center of the tree is the tree's first year of growth. You can determine different things about tree's life by inspecting the tree rings. A large ring likely means that the tree had good growing weather, while a thin ring probably means that the weather was dry that year, making it difficult for the tree to increase in size very much. You can see concentric circles on rare occasions in the sky. Here is a picture of a moon halo, which is also called a 22-degree halo. This phenomenon occurs because cirrus clouds, type of thin, high-altitude cloud, are made up of tiny frozen droplets of water. These bits of ice reflect and refract the light, making you see a 22-degree halo. The name originated because when these halos appear, the light bends 22 degrees towards the observer as seen in this diagram. These halos can also appear around the sun. The paths the planets take around the sun form concentric circle too. Each planet has the same path it takes every year, and these elliptical orbits look similar to larger and larger ovals. Concentric circles can be found in various food. As well, if I cut this cantaloupe in half, I can see the seedy part surrounded by the flesh and the rind. This kiwi has a similar structure, and this mandarin has concentric circles as well. You can probably find many more concentric circles in fruits, vegetables, or even eggs. Doodling concentric circles can be a fun activity. You can see how many you can fit on a page or use different colors and make art. You can also make a loopy squiggle and then draw another squiggle around it. It's not really a concentric circle, but it still looks interesting as you draw. As you do, the squiggle loses its squiggliness and reverts to a circle-like shape. If you do not want this to happen, you can accentuate the squiggles and get funny-looking shapes like this. Another interesting repetitive pattern is tessellations. Tessellations are rather open to interruption because any repeating pattern without gaps or large overlaps is considered a tessellation. The skin of a snake, the mesoscale pattern on a leaf when you look at it closely, or even the sand in the desert can be a tessellation. You can find tessellations all over the place. and often the pattern will feel interesting beneath your fingers. The tessellating pattern of a honeycomb is particularly fascinating, but that is something we can look at next time.
Number 1. What math concept is fully discussed in your assigned video? It is all about the tessellations that repeats to make a pattern. There are 3 basic shapes of tessellations such as triangles, hexagons, and also squares. There are 3 rules of tessellations: translations, rotations, and grid reflections. Number 2. What is about this concept? Cite few more real-world cases or example that would show the concept. A tessellation is a repeating pattern without gaps or large overlaps. Examples are tile floor, oriental carpets, Islamic architectures by the use of geometric shapes. Number 3. What are your insight about these mathematical truths or certainties? My insight about mathematical truths or certainties is mathematical truth is a conformity of thought to the laws of logic in terms of a concept, propositions, inference, and etc.
What math concept is fully discussed in your assigned video? It's all about tessellation. Tessellation is a shape that repeats to make a pattern. And there are 3 basic shapes in tessellation pattern, such as triangle, hexagons, and squares. Also, there are 3 rules, such as tessellation, number 2 is rotation, and 3 is glide reflection. My answer in the first question is tessellation is a tiling over a plane with one or more figures, such as the figures fill the plane with no overlaps and no gaps. And the second question is, what is about this concept? Cite few more real-world cases or example. The example in real world tessellation is tile floor, brick, blocks, walls, and checker or chessboards, and fabric pattern. My answer in question number 3, what are your insight about this mathematical truth or certainties? The answer is, tessellation is a pattern in which geometric figures repeat without any gaps between them. The figure is the same on all sides and will repeat together when it is repeated because the tessellates tend to be regular polygons on coincident sides.
Number 1. What math concept is fully discussed on your assigned video? It is all about a tessellation, a shape that repeats to make a pattern. There are 3 basic shapes of tessellation: triangle, hexagons, and squares. There are 3 rules of tessellation: translation, rotation, and glide reflection. Number 2. What is about this concept? Cite few more real-world cases or examples that would show the concept. A tessellation is an arrangement of shapes that fitted closely together and repeated pattern without gaps or overlapping. Examples are a tile floor, fabric pattern, and a chessboard. What are your insight about this mathematical truth or certainties? I thought this is truth because it consists a relationship to reality involving a characteristic relation.
What math concept is fully discussed in your assigned video? Tessellation is a shape that repeats to make a pattern. There are 3 basic shapes tessellation pattern. First is the triangle, second the hexagon, and the third is the squares. So there are 3 rules. First is the tessellation, rotation, grid reflection. When drawing tessellation patterns, symmetry is the mathematical idea that can be used. Symmetry is the preservation of form and configuring across a point line or a plane. Symmetry of an object in the plane of regained motion of the plan that leaves object apparently unchanged. concept about? Cite few more real-world cases or example. A tessellation is created when shape is repeated over and over again, covering a plane without any gaps or overlaps. Another word of the tessellation is a pinning, where you fit individual tiles together with no gaps or overlap to fill up a flat space like a ceiling, wall, or floor. You have a tiling. What are your insights about this mathematical truth or certainties? Tessellation can be found in many areas of life: art, architecture, hobbies, and many others. Idea hold examples of tessellations found in our every surrounding. Specific examples include oriental carpets, quilts, origami, Islamic architecture.
What is tessellation? A tessellation is a shape that repeats to make a pattern. So, there are three basic shapes of tessellation: a triangle, hexagon, and square. And the three roles are translation, rotation, and light reflection. So, the first question is, what math concept is fully discussed on your assigned video? The answer is tessellation. The second question is, what is concept about? So, tessellation is created when a shape repeats to make a pattern, covering shape namely triangle, hexagons, and squares, and has three roles, which are translation, rotation, and light reflection. So, can be seen in a variety of mediums, including art, architecture, hobbies, and many other fields. Oriental carpets, quilts, origami, Islamic architecture, and MC Skir's work are just a few examples. Tessellation can be found on oriental carpets in an indirect way. What are your insights about the mathematical truths and certainties? So, in tessellation, whenever two or more polygons meet at a point or vertex, the internal angles must add to 360. This continues until infinity. These mathematical truths have may backing because they clearly illustrate and demonstrate how tessellation continue or can go on forever.
Hi, my name is Chiana. Question number 1. What math concept is fully discussed on your assigned video? Concentric circles are circles with a common center. There are two or more objects are said to be concentric, causal, or causial when they share the same center or axis. Any two circles can be made concentric by inversion by picking the inversion center as one of the limiting points. Question number 2. What is about concept? Cite few more real world cases or examples that would show our concept. Concentric circles having the same center but different radii. Here the given figure we observe that the three circles C1, C2, and C3 are the concentric circles. They have the same center circles but they have different radii. Circles A, B, and C are not equal, hence the three circles are concentric. Question number 3. What are your insight about these mathematical truths or certainties? It helps you to develop yourself to guide in knowing your inner self. But the concept of certainties is circumscribed and limited to human, knowing that mathematical knowledge does not constitute object truth. Thank you.
Number 1. What math concept is fully discussed on your assigned video? It's all about distillations. There are shapes and repeats to make a pattern, and there are 3 basic steps of distillations. The triangles, hexagon, and also square. And there are 3 basic shapes of distillation: the transition, rotation, and glide reflection. Thank you. Number 2. What is about this concept? Cite few more real-world cases or examples that will show the concept. A distillation is a pattern of a repeating shape or shapes that covers a plane with no gaps or overlaps. Examples are checkerboard, tile floor, or rental carpet by the use of geometric shapes. My deep understanding of this concept or this video is math is not all about the numbers but also an arts, because there shows shapes, patterns, and design.
What math concept is well discussed in your assigned video? It's all about a tessellation, a shape that repeats to make a pattern. So they have 3 basic shapes and rules of tessellation. The 3 basic shape of tessellation is triangles, hexagons, and square. And the rule of tessellation is translation, rotation, and glade reflection. Number 2. What is about this concept? Cite few more real-world cases or examples that will show this concept. A tessellation is created when a shape is repeated over and over again, covering a plane without any gaps or overlaps. The example of tessellation is a tile floor, a brick or block wall, checker or chessboard, and a fabric pattern. Number 3. What are your insights about these mathematical truths or certainties? The kind of truth you get in math is a rather low level of truth. Tautological truth, physicists use math as a tool. The choice of what math to use has to be part of the input and empirical choice. That's all. Thank you.
What math concept is fully discussed in your assigned video? It is all about tessellation, a shape that repeated to make a pattern. There are 3 basic shapes tessellate. These are the triangles, hexagons, and squares. And there are 3 rules of tessellation: the translation, the rotation, and the glide reflection. What is about this concept? Cite few more real-world cases or examples that will show the concept. Tessellation is a tiling over a plane with one or more figure, such that the figures fill the plane with no overlaps and no gaps. Example of a tessellation are a tile floor, a brick wall, a checker or chessboard, and fabric patterns. What are your insights about these mathematical truths and certainties? Mathematical truths and laws were formulated to define things happening on Earth because of the curiosity of the previous generation. They found a pattern on Earth which led to them to the discovery of these laws, and in turn these laws could be used as a guide in predicting futures, events, and solving mysteries in life.
What is all about this concept?
or more